Today I'm going to be teaching you about wave speed. So first let's define what is a wave. A wave is basically a disturbance that can cause matter to oscillate up and down or back and forth with the result of transporting energy from one place to another. So that's basically it. It is caused by something, a disturbance. If I flick my arms, or if I punch a wall, it will basically produce sound. And that sound travels in waves. So we have two types of wave. We have transverse waves, which is the normal one, and the longitudinal wave. So on transverse waves, the example here is going to be the light. And on longitudinal waves, I hope I'm pronouncing that right, we have sound waves. So basically it is caused by a medium disturbance. So in typical wave, we have this thing. In typical wave, this is the basic illustration of it. Crest is on the top and trough is our trough. Just trough, I think. And in the bottom, that is the lowest point, not point or the lowest thing. So we have different equations here. We have period and frequency. This is the period for frequency. So the period is basically time per cycle and frequency is cycle per time. So we have the basic wave equation, which is velocity is equals to wavelength times frequency. This is very important for wave speed. And we also have equations in wave in a string. So we all know that to illustrate wave in the best illustration, we need it in a wave of string. So we actually have speed of sounds here and facts about humans. We can hear sound at 20 hertz to 20,000 hertz, and that's it. Okay, now let's move on to our problem. A tension force of 50 newtons is applied to a 0.5 kilogram of wire that is 5 meters long. The wavelength of the wire is zero point 0.5 meters. So what is the speed of the wave and what is the frequency? To solve this problem, I already have some equations here on the top left. So to get the speed, we just need to use the velocity of wave equation. So the tension force is going to become 50 newtons. So we need to calculate the mu. It is the linear density. It's going to be mass over liters. Our mass is going to be 0.5 kilograms, and our length is the length of the wire is going to be 5 meters. So we will have this thing. So we will get 0.1 kilogram per meter. So this is the linear density of this wire. So putting it here, and then just using our calculator, we can just basically answer this thing. So the velocity of the wire is going to be 12.247 meters per second. Now how about how we can calculate the frequency? So let's do it. So we have the given here, that is the wavelength of the wire. So we can just use the basic wave equation to solve that problem, to solve for the frequency. So B, we all know that velocity is just equals to wavelength times the frequency, and we now know that what is the velocity. So the velocity is 12.247, and our wavelength is going to be 0.5 multiplied by the frequency, dividing both sides by 1/2, or 0.5 is going to be, so the frequency of this thing is 24.4995 hertz. So hertz is the unit for frequency. We all know that because we can just hear for 20 hertz the facts about humans earlier. So that is the frequency. It's 24.495 hertz. Now let's move on to our second problem. The crest of a water wave passes about every 2 seconds. The wave crests are 10 meters apart. What is the period? What is the frequency? What is the wavelength? What is the wave speed? Okay now. So we can already know what is the period. It's going to become 2 seconds because it basically passes about every 2 seconds, right? We can know the frequency also because frequency is just 1 over t, which is going to become 1 half or zero point 0.5. So that is the frequency. So it is not that frequent. The wave are pretty much slow, right? So now let's calculate the wavelength. So we're not going to calculate actually because it was already given. The wave crests are 10 meters apart, which means the wavelengths are just basically 10 meters too. So to calculate the wave speed, what we need to do is the basic wave equation. So velocity is going to become 10 meters times the time, which is zero point 0.5. This is going to be 5 meters per second. So it is pretty much slow. So these waves are slow because it is a water wave. So if it is a tsunami, then therefore it's just going to become high. Oh, what is that? What tension force is required to create a wave that has a wavelength of 15 meters and a frequency of 3 Hz using a string that has a linear density of 0.75 kilograms per meter? So let's list down our given. So our wavelength is going to become 15 meters, our frequency is 3 Hz, and our linear density is 0.75 kilograms per meter. So what we're trying to calculate here is the tension force that we need. So how much tension force we need to able to produce these things? So first of all, we need to calculate velocity because we do not have that in our equation. We're gonna do the algebra. So this is just going to be 15 times 3, which is no, not 75. I'm just kidding here, right? It is going to become 15 times 2 is 30 plus another 15 that is going to become 45. So the velocity is 45 meters per second. So now we can just use simple algebra to calculate this problem. We're just going to plug in what we know. So our velocity is going to become 45. And then our tension force, that is what we're going to calculate. Our linear density is 0.75. We can just delete velocity here, get out. Now we can just take the square root, no, not square root. Let's raise both equation by the second power to get rid of the square root. So we got 45 here. I actually deleted in, but I'm still going to continue this, and we got this. So the radical sign will cancel, and we have this thing. So cross multiply, that is the answer. So the tension force is going to become this number. It's around 1000. It's actually 1518.75 newtons. So we need this force unable to produce this 45 meters per second wave. How long will it take a wave traveling from one end of a 100-meter long wire to the other end if a tension force is applied to the 10 kilogram wire? So this is a wire. This is just red. So the wire is actually 100 meters long. So the distance is also 100 meters, right? And the length is going to be 100 meters. So let's list down what we know. So frequency is what we're looking for. No. Time. I thought that's F. So the tension force is 10 kilograms. And what we're given here. Oh, we can actually use this formula. Density is equals to the average velocity times time. You know your Newtonian mechanics back then, kinematics. So we have the distance, but we do not know what is the average velocity. So we can just use this equation. We can use the velocity of wave equation on a string, but we do not know the linear density, so we'll just calculate it. Our mass is 10 kilograms, and our linear density is going to become 100. The length is going to become 100. So just 0.1 kilograms per meters. Now we can just plug it in into our velocity of wave equation. No, not meters squared, but meters. So here we go. And now 10 divided by 0.1, and then take the square root of it. We got this. So the wave traveling at 10 meters per second. That's fast. Then we can just use this equation to calculate the time. So time is just 10 seconds. So we need 10 seconds in order for us to reach one end to another. And that's it for this video.